Hello there, we're back. This time, we're doing a little demonstration, specifically 3 ways to find equivalent fractions. Remember, equivalent fractions are just different fractions of the same size. They look different, but they actually are worth the same amount. And there's 3 ways we're going to do this. And this is a perfect time to remind ourselves of one of our big ideas, and that's this, a big idea. There are many ways to write numbers. And equivalent fractions just demonstrate that there's more than one way to write the same number. So here we go. The first way we're going to do it, let's get this guy out here, is visually. So here I have a box that I'm saying is 0 at this end and 1 at this end, and I need to split this thing up. And let's, I want to split this up into quarters. So I'm going to split it in half here. I'll split in half one more time. So I have 1, 2, 3 fourths. So I've got 4 fourths. But say I was only interested in 3 of these. So if I just highlight this part right here, I can ask the question how much is highlighted. Lo and behold, we can all see that 3 fourths are highlighted. Well, this 3 fourths is not going to change, but is it true that I could break up my boxes into different sizes? Sure, I can do that. So tell you what, let me split up each of my boxes in half. So I'll split this one in half. I'll use a dot here, line here, just to indicate that I'm splitting each of these in halves. So the amount that I've highlighted hasn't changed. But now, instead of having 4 equal size boxes between 0 and 1, I have 1, 2, 3, 4, 5, 6, 7, 8 equal size boxes. And how many are highlighted? Well, 1, 2, 3, 4, 5, 6. 6 are highlighted. So the amount I've shaded hasn't changed, but the number of equal size boxes that make up the shaded portion is a different number now. So there we go. I can simply take an amount that I have, a fraction I have, and if I could divide up that evenly in some way, then lo and behold, I have the same fraction. This was much like the number lines that we looked at last week that looked like this, where here was 1, here are halves, thirds. Here was my 3/4. There's 3/4. And if I simply draw a line down here until I meet up with something that it matches up with, like this, so here are my quarters. These are fifths, sixths, sevenths, and eighths. So this is 1/8. And lo and behold, the same distance shaded here so that my shading matches up. I have 1, 2, 3, 4, 5, 6 shaded. There's visual. Another way that we showed in class was by multiplying or dividing the numerator. Remember, numerator, that's the top of the fraction. And denominator, also known as the bottom of the fraction, by the same value. So in this case, if I have my 3/4 and I multiply top and bottom by the same amount, say 2, when I do the computation, 3 times 2 is 6, 4 times 2 is 8. So lo and behold, I get the same thing as what I did visually. And we asked the question, why does this work? Well, when we look at this particular fraction here, 2/2, well, 2/2 is simply the division problem, 2 divided by 2. And so this right here is actually worth 1. Anytime you multiply something by 1, it doesn't change the value. Now, we've written it differently, but it doesn't change the size of what's being described. The other way is using, so this was way 1, right? This is way 2. I'll write it with Roman numerals. And so Roman numeral 3. Our third way that we did in class is using the multiplication table, or as we multiplication table. So everyone was handed a multiplication table. And we observed that when we had a fraction like 3/4, all we simply have to do is, if we go over the same amount and we multiply top and bottom by the value at the top of the multiplication table, so 3 times 2 is 6, and 4 times 2 is 8, we get an equivalent fraction. And it works like that all the way across the multiplication table. Multiply 3 times by 3, we get 9. 4 times 3, we get 12. If we multiply 3 times 4, we get 12. If we multiply 4 times 4, we get 16. So the entire multiplication table is also an equivalent fractions table. Equivalent fractions table. So just as we multiplied top and bottom by 2, we did the same thing here. There is, so 3/4 is equal to 6/8. And this works for as long as the values you're choosing are lined up on top and bottom of each other. So say we did something like the fraction 9/13. 9/13. So 9/13. Let's multiply top and bottom by 4. If we do that, we have 36 over 52. If we look at our multiplication table, here's 9. If we go to the 4's column, we have 36. 13 is 52. So there's our fraction, 36, 52. So there you go. There's our 3 ways we can write equivalent fractions. And hopefully this does a good job of illustrating the big idea that there are many ways to write numbers. You guys have a great day.